find the equation of the line segment joining the given pair of points. So here we have 2 points. We have the origin, which we'll label as point A, and we have the point 10, 9, 10, which we will label as point B. So here we want the equation of the line segment. So everything will be the same except the bounds on T. So be careful as you proceed. So again, the ultimate goal is to find the vector valued equation of the line, vector r of t, which is defined as the position vector plus t times vector v, and this will be such that t is going to be greater than or equal to some value a, less than or equal to some value b, where a and b are scalars. So here we go. The process is the same as the equation of the line, or the parametric equations of the line. So we start by choosing a point for P naught. Choose P naught, and either point will work. So I'm going to go ahead and let P naught be the origin, 0, 0, 0. But again, keep in mind that P naught being equal to 10, 9, 10 also works. So from this P naught, we can define the position vector. So we know that vector r naught, the position vector, is the directed line segment from the origin to the point P naught. Oops, we have the origin to the origin, so our position vector is the 0 vector. So now that we have our position vector and our point P naught, let's go ahead and define the parallel vector. So we need to find vector v. And again, we have 2 options here. We can let vector v be defined as the directed line segment from point A to point B, or we could let vector v be defined as the directed line segment from point B to point A. So pick your favorite method. So I'm going to use vector v is defined as the directed line segment from point A to point B. So here we go. Again, this is terminal minus initial, so I have 10 minus 0, 9 minus 0, 10 minus 0, for a parallel vector defined as 10, 9, 10. And we have all of our pieces. We are ready to define the equation of the line segment. So we want to find the line. So we have vector r of t, again, is going to be equal to that position vector plus the parameter t multiplied by the parallel vector v. So we have the 0 vector plus our parameter t multiplied by the parallel vector 10, 9, 10. And so this leaves us with the vector 10t, 9t, 10t. Now, be careful. We're not done yet. Right? This is a line segment, so we're going to exercise a little caution here. We still need to find the bounds. So line segments have bounds. But fortunately, finding these bounds is very straightforward. So keep in mind, looking up at our previous step here, we have the vector valued equation of the line. So this is your x of t, y of t, z of t. So we are going to use this with the 2 initial points that were given to find the bounds. So we need more room. So we'll need to think of 2 cases, one for each point. So case number 1, we need to think about the point x, y, z being defined as point A, which was simply the origin. So now we are going to equate the parametric equations to their corresponding components to solve for t. So this means that x of t, which is 10t, is going to be set equal to 0. we're going to have y of t, which is 9t, is going to be set equal to 0. And we have z of t, which is also defined as 10t, is going to be set equal to 0. So we have our three cases, and we should get the same answer every time. And we can see that we do. We're ending up with t is equal to 0. Every time, all the time. So t equals 0 surely looks like a bound. Now we want to do the same thing with the second point that we're given. We're going to let x, y, z, in this case, be defined by the point B, which is the ordered triplet 10, 9, 10. And we'll do the same thing as case 1. We are going to take x of t, which is defined here as 10 of t, and equate this to x, which is 10. We're going to take y of t, which is defined here as 9 of t, and equate this to y, which is 9. And we take z of t, which here is also 10t, and we equate this to z, which is 10. And again, we should get the same answer every time. And we do. Dividing both sides by 10, we get t is 1. Dividing both sides by 9, we see that t is 1. And last but not least, again, dividing both sides by 10, we see that t is equal to 1. So this is letting us know the bounds on our line segment. So we can claim now that the equation of the line segment is defined as follows. So our beautiful final answer, we have the line segment vector r of t is defined by the components 10t, 9t, 10t, and this is such that t is greater than or equal to 0, less than or equal to 1. And this is one possible beautiful final answer.